Topic: Saline features of world's physical geography including India. Q. Discuss the ideal conditions for formation of coral reefs. Also discuss the theories of coral reef formation. 250 words background. Corals are nothing but calcareous rocks, formed from the skeletons of minute sea animals, called polyps. The polyps extract calcium salts from seawater to form hard skeletons which protect their soft bodies. These skeletons give rise to corals. The ideal conditions for formation of coral reefs. Sunlight. Corals need to grow in shallow water where sunlight can reach them. Corals depend on the zooxanthellae algae that grow inside of them for oxygen and other things, and since these algae need sunlight to survive, corals also need sunlight to survive. Corals rarely develop in water deeper than 165 feet 50 meters. Clear water. Corals need clear water that lets sunlight through. They don't thrive well when the water is opaque. Sediment and plankton can cloud water, which decreases the amount of sunlight that reaches the zooxanthellae. Corals, in order to grow, also need plentiful supply of plankton and enough oxygen. This is important because, like any other living organism, corals polyps need food and oxygen so as to grow and be able to reproduce. Warm water temperature. Rebuilding corals require warm water conditions to survive. Different corals living in different regions can withstand various temperature fluctuations. However, corals generally live in water temperatures of 68 to 90 degrees F or 20 to 32 degrees C. Clean water. Corals are sensitive to pollution and sediments. Sediment can create cloudy water and be deposited on corals, blocking out the sun and harming the polyps. Wastewater discharged into the ocean near the reef can contain too many nutrients that cause weeds to overgrow the reef. Saltwater. Corals need salt water to survive and require a certain balance in the ratio of salt to water. This is why corals don't live estuaries. Ocean currents and waves are favorable for corals because they bring necessary food supply for the polyps. Corals grow in open seas and oceans, but they die in lagoons and small enclosed seas because of lack of supply of food. Currents and waves also determine the shapes of coral reefs. There should be extensive submarine platforms for the formation of colonies by the coral polyps. Such platforms should not be more than 50 fathoms 300 feet or 91 meters below sea level. Theories. 1. Darwin's subsidence theory. Darwin assumes that along a suitable platform, coral polyps flopped together and grew upward towards a low water level. The resulting reef, in this stable condition, would be a fringing reef. But, at the same time, Darwin assumes the sea floor and the projecting land in coral seas started submerging, and the living corals found themselves in deeper waters. Hence, an urge to grow upward and outward would be balanced by the subsidence of the land. As a result of this, Darwin postulated that the fringing reef, barrier reefs and atolls are only 3 stages in the evolutionary growth of a reef. As the land subsides, the fringing reef would grow upwards and outwards, resulting in the formation of a shallow lagoon. Further subsidence would convert it into a barrier reef with wide and comparatively deeper lagoon. The theory implies that the barrier reef and atoll can occur only in the areas of submergence, and the great amount of vertical thickness of coral material is primarily due to the subsidence of land and consequent upward growth of coral polyps. There is much evidence of subsidence in coral areas. For example, submerged valleys in the east of Indonesia and the coastal areas of Queensland. Only subsidence can explain existence of corals at this depth because, generally, corals cannot grow below 100 meters. Criticism. Corals have developed in places where there is no evidence of subsidence. For instance, Timor. Also, the question arises as to why there is uniform subsidence in the tropical and subtropical areas and not so in other areas. 2. Murray's non-subsidence theory. According to him, coral polyps can live up to the depth of 30 fathoms 180 feet. Sea level and submarine platforms are stable. Several submarine platforms, volcanic peaks, islands are present below sea level. If the submarine land platforms are above the permissible depth for the survival of coral polyps 180 feet, they are subjected to wave erosion so that their heights are lowered down. Thus, the continuously outward growing fringing reef is transformed into barrier reef in due course of time. The lagoon is formed between the land and barrier reef because of dissolution of dead corals. Atolls are formed due to outward growth of corals in all directions at the top of submarine platforms. Thus, a ring of coral reef is formed around the solution lagoon. Criticism. Murray's theory requires the existence of numerous suitable submarine platforms depth of 180 feet, but the existence of such features is not possible. Murray has described two contradictory views of marine erosion and deposition at the depth of 30 fathoms 180 feet at the same time over different submarine peaks. Such proposition is not possible. The limit of 30 fathoms for deposition and erosion cannot be accepted. 3. Daly's glacial control theory. When the ice age ended, the temperature started rising and the ice sheet melted. The water returned to the sea, which started rising. Due to the rise in temperature and sea level, corals again started growing over the platforms, which were lowered due to marine erosion. As the sea level rose, the coral colonies also rose. The coral colonies developed more on the circumference of the platforms because food and other facilities were better available there than anywhere else. Hence, the shape of coral reefs took the form of the edges of submerged platforms. The greatest merit of this hypothesis is that it needs no subsidence of the crust, as is the case with Darwin's hypothesis. Finally, the sea waves and currents could have easily cut down the islands and converted them into low platforms. Criticism. Daly could not explain the existences of coral colonies at depths of 100 meters. 4. Davis' application of physiography to the problem of origin of coral reefs. Davis reasserted the validity of submergence. Davis has also taken into consideration the facts of changing sea level. According to him, lowered sea level on subsiding islands would also create cliffs and spurs, but most of them would be protected by reefs along their shores from wave attack, hence cliffs would not be seen. Further, subsidence would also drown such cliffs if they were formed. Thus, this theory advocates the old idea of subsidence with renewed application of physiography. It is also comprehensive in its application as it includes the changes of the CLEVL as well as the tectonic changes of the land mass. Criticism. In spite of the above evidence, one fact is left unexplained: the assumed equal depth of the lagoons. Conclusion. Coral reefs protect coastlines from the damaging effects of wave action and tropical storms, provide habitats and shelter for many marine organisms. So protecting them is imperative.